Hi guys. Alright, today's lesson is about how to pull information off of the periodic table. So you need to have out your periodic table and this notes and the homework that looks like this. Atomic structure worksheet number 1. We're going to start out on the notes with a summary of what we know is inside the atom. Protons, neutrons, and electrons. Okay, protons, if you haven't figured it out, their symbol is a P with a little positive sign above it. Their charge is a positive 1 charge. Their mass is something really tiny. It's 1.67 times 10 to the negative 26 kilograms. So that's like a 0.000, 26 zeros. So it's a very tiny amount. So we actually just define that as a new unit called an atomic mass unit. So we say a proton weighs 1 AMU, or atomic mass unit. And it's located in the nucleus. Likewise, the neutron, its symbol is a lowercase n with a little degree sign above it, or a 0, because it has no charge. It's neutral. Its mass is approximately equal to that of a proton. So we say its mass is equal to 1 AMU, atomic mass unit. It's also located in the nucleus. The electron, its symbol is a lowercase e with a negative sign. Its charge is a negative 1. So we say it has a charge equal in magnitude and opposite in direction from a proton. 1 electron can cancel out 1 proton. Its mass is tiny. Now, we know that the atom is tiny, and that compared to the atom, the nucleus is tiny. And even compared to that, the electron is even smaller. So we don't even count the mass of the electron, even compared to a proton. We say that its mass is approximately 0, because we think of it more like a wave or like light, which doesn't have mass. And it's located in the concentric circles around the nucleus, called the electron cloud. Okay, so those things, if I flip over to the homework here, we just hit these categories: number of protons, number of neutrons, and number of electrons. We're going to continue defining a few other vocabulary words and then come back to this worksheet. So the homework, the notes. Atomic number. Atomic number is the big main number on the periodic table, and it is the number of protons that an atom has. This is what identifies an atom. So number 6 on your periodic table is carbon. Go ahead and find it. If any atom has 6 protons, we call it carbon. That's how you identify carbon. So this is what identifies an element. And when Dmitri Mendeleev put together the periodic table, this is how he arranged it. He arranged it in increasing order of atomic number. So the periodic table is in this order. Mass number. The word mass means how much something weighs. So the only 2 subatomic particles that weigh anything, since the electrons are so small, are the protons and the neutrons. They each weigh 1. So if we want to know the mass of a given atom, we add together the protons plus the neutrons. Mass number equals protons plus neutrons. This should always give you a whole number. And whereas average atomic weight, our next vocab word, will refer to the average of a group of atoms, mass number refers to one specific atom. Refers to a specific atom. The mass number is not on the periodic table. The average atomic weight is on the periodic table. It's usually a decimal. And it refers to the average of a whole group of atoms of a given element. Refers to a group of atoms. Let's use carbon as an example again. Find carbon. It's number 6, atomic number 6, and it has the average atomic weight written below, 12.01. Now, no carbon atom actually weighs 12.01 AMUs. They either weigh 12, and then a few of them weigh 13, a few of them weigh 14, and when you average all of them together, you get an average that's slightly above 12. That's why we have the decimal number 12.01. Now these atoms that weigh different amounts than they're supposed to are called isotopes. Like a carbon that weighs 13 or a carbon that weighs 14. Now how can that happen? If you add a proton to it, it won't be carbon anymore because it won't have an atomic number of 6. It would be nitrogen or oxygen. If you add electrons to it, that's not going to do anything because electrons don't weigh anything. It's not going to change the weight. So the only way that you can keep it as carbon and still change the mass of it is to add a neutron. So an isotope is an atom with more or fewer neutrons than is normal for that element. Now, how do you know what's normal? You look at the average. Average is another word for normal. So if I have a carbon atom that weighs 12, I look at carbon's weight of 12.01, I round it to the nearest whole number, that's 12, and so I probably have a normal carbon atom with a normal amount of neutrons. If I have a carbon that's anything different than 12, I would call that an isotope. We're going to skip down to ions. An ion is an atom with a charge. An atom with a charge. So if I have 6 protons and 6 electrons, that's a neutral atom. It does not have a charge. But if my protons and electrons differ, if I have more protons, I'll have a positive ion. If I have more electrons, I'll have a negative ion. I'm going to skip isobars and go to period. Period refers to what row you're on the periodic table. So if you're looking at your periodic table like this, 1, 2, 3, those are periods, whereas group numbers are the columns. Counting this way across the periodic table. So you can also identify any atom on the periodic table by giving its period and group number. Okay. Armed with those vocabulary words, we are going to try to practice pulling information off of the periodic table and just get good at reading it. So the nice thing about the periodic table is you don't have to memorize a lot of stuff, but you do need to be able to pull out the information that you need quickly. So let's jump to the homework and try a couple things here. A 12.011 is the average atomic weight. We know that that's carbon. We were just looking at that, so I can name this one carbon. Symbol is C. We see that the period is number 14. It's in the 14th row. It's the, sorry, back it up. It's in the second period. It's the second row down. 14th group number, 14th column. The atomic number is 6, which is the same, always the same as the number of protons. So we've got all that information just by finding it on the periodic table. The next 3 columns are a little trickier. On this particular worksheet, we're going to make 2 assumptions. We're going to assume that there are no ions. That means no atoms with a charge. So if I have 6 positive protons, I better have 6 negative electrons as well. So I can put a 6 here for electrons. The second assumption is that we're going to assume on this sheet that there are no isotopes. That means that my mass number better match whatever is normal for carbon. So I can round 12.011 to the nearest whole number and just say that my mass number is 12. Finally, I'm going to use the definition of mass number. Remember from your notes here. Mass number is equal to protons plus neutrons. So I have to be able to add together protons plus some number of neutrons to get to 12. 12 minus 6 is 6, so I have 6 neutrons. Now, don't fall into the trap here. This happens about half the time that these 2 columns, protons and neutrons, are the same, but it's just a coincidence. They don't have to be the same. Just tends to happen a lot. The real way that we got this was that protons plus neutrons had to add up to the mass number. With that information, guys, I want you to see if you can fill out the rest of this worksheet.